Hi everybody, this is Katie Vandermeer. In this video I'm going to show you quickly how to use the Sandbox. Now in the other videos you'll see how to download and install required software and then how to create a program in Visual Studio. Now Visual Studio is a separate entity, so you can install this piece of software, you can run it aside from Netacad or Blackboard. It's a totally different beast. So you create programs in here and code them in there, and you can create executables. It's a very powerful program, and I do recommend it. But in the meantime, before you get to all that set up and running in the Visual Studio environment, Netacad provides us with the Sandbox environment. And a sandbox is just a place that allows us to code. So when we look at the modules, we have you'll see two things. One is the Sandbox labs, and then the other is just the sandbox itself. So, well, there's the labs and then the sandbox. A sandbox by itself, this link right here, launches an empty workspace. Now this is kind of similar to what you would see in Visual Studio when you create a new project. Let's see. Let's see if this opens one. I kind of moved a lot of my files around, but in the Sandbox, you'll see something similar to what you see in the Visual Studio environment or any other compiler that you're using. You have kind of this blank space where you add code. Ignore that. CPP file, these are code files. So you kind of have the same environment. You know, this is where I would code in a C++ in Visual Studio. So in the other video, I'll show you how to code in here and how to set up that. But the Sandbox, again, is very similar. But it's web-based, and it's limited in the functionality. That's why it's good to have a separate compiler. But it's also very useful for us when we're just learning the language, because we can just test it out without having to deal with the whole new compiler. So that's what is here. If we're working in the Sandbox and I say, run this program in a compiler and see what happens, you can either, you could open up a file that's already a CPP file, which is the extension for all C++ files, or you could just type your own code that you want to test out. And this is, it's nice, like if I open up a parenthesis, it'll close a parenthesis, and open up a curly brace, it will close the curly brace. So it does have some features, but not the extent of what a full compiler would have. So the Sandbox is nice. You can use it to test things out, test a piece of code. One of the other things you'll see in Netacad is you'll see a link to the labs. Now these are the labs we're going to do for our homework assignment. I'm not going to assign all of the labs. So in Blackboard, when you go through the modules, when you go through the assignment link, and it will say, okay, in Unit 2, do this lab, and such labs. Then you're going to go to Netacad. You'll read the chapter first. There's another video that shows you how to progress through the chapter, and make sure you read all of the pages of this and how to use it all, because this is what the labs are based off of. So you need to read and understand what's going on in here first. It's your textbook. So you'll read that through Netacad, and then you'll come across different labs. Now the labs that you see here are the labs that are also in that Sandbox lab. So it'll open up. Now we're going to do lab 141. So I'm going to open up here. Oops, back. Let's say view all pages. These are just all of the pages of the modules. Yep, slow. So those are all the labs that you'll see. These labs are all of the labs. There's maybe 100 of them, maybe not that many. We're not doing them all, so don't worry. But all of those labs are the labs that you'll see in the environment, the Sandbox labs. Show you how to get back to that. So that page is kind of confusing, but that's there. When you're going through the chapter again and you come across a lab, you can open that lab up in this area. So we're gonna, let's see, 1.4 labs. That 3 means there's 3 labs associated with that section, and you can open it up here in Netacad, or if you go over to the Sandbox, you'll see the lab there too. If you are using a separate compiler, you can take this PDF file and build your program from that PDF. Or if you're using the Sandbox, let's go over there, and that's what I want to show you how to use in this video. The slowness is not the Netacad software that you see on my laptop or on my computer. My internet is pretty slow this morning. Okay, so here I'm going to go to the Sandbox lab. So I'm not sure what that is. So here I'll open up the lab. It opens up in a new environment. And over here, click on lab assignments. You'll see all of the labs for all of the chapters that we cover. So I will say, for example, in Blackboard, I'll say do lab 1.4.1, which is this one. And I'll give you the name because notice that these numbers are what you see over in Netacad, but on the PDF form it would say 141 instead of that 40. That has to do with the page numbers and how it's laid out. But it'll be very clear on what assignment you're going to do. Okay, so I want to show you how to use the Sandbox. So open up Netacad if you haven't already and get to this place because this is the lab we're going to do together just to show you how to use the Sandbox. So when I go to that area, you can see here are the objectives, and then the scenario is really your problem. So the objectives are what you're going to know at the end of this program, and then the scenario is what you code. So it says, take a look at this code below, and it reads a float value, so it reads in a value, and then it puts it into a variable named x and prints the value of the variable named y. So your task is to make it do all of these mathematical things. So, and then display the value of y. And again, you can use another compiler to do that, or you can use the Sandbox. Now, the Sandbox already sets up some basic things. So it has our header information, and we can add to this however you want. You know, you would always put who you are. These are just comments, you know, the date, and you know what lab number this is, 1.4.1, floats. You can add any code you want to here, which is the point because we want to interpret this answer. So here's the workspace, and then down here is the console, which is what you expect to see as your output. It's done differently over here. You get a actual black box that comes up, and that's your program. But again, that other video shows you how to do that. So here we're adding our code. You'll learn before or as you get into the class, what each of these statements mean. So I'm not going to explain that in this video because I really just want to show you the environment and show you how to code something and then what to expect, like if you have errors. So here, we got to put our code here. What do we have to put? We have to interpret we have to figure out what y is. Well, y equals x raised to the power of 2 divided by pi squared, and then you multiply that by x2 plus a half divided by 1 plus x squared, and so on. Okay, that's very frightening. It's frightening to me, so I'm just going to erase that. The 2 slashes are common, so the answer to y is what we're going to calculate now. Okay. So it gives us a couple of hints, so you want to read this lab through carefully. It says we've prepared a variable containing the value of pi. Look at it, it's right here. The variable is pi, name, and it stores the value. So anytime you want to multiply, when it says pi squared, you would just you don't have to type in 3.1415 and so on. You just use the variable pi. So there's a hint. Watch the operators and keep the priorities in mind. Part of this lab is showing you the order of operations. So it's showing you where to use parentheses. So we want to be careful on that. And then to do pi squared, just do x times x, because there's no, like in math, you would do pi, or something like x raised to the power of 2. That does not work in programming. So you would just do x times x is what they're telling you. So always read the hints, because you learn a little bit about what you're supposed to code. Also, if you're stuck on interpreting what you're supposed to do, send me an email and I will help you figure that out. Okay, once you've coded your answer, then then they always give you test data. So it says if you put in 1, this is what your out should be. If you put in negative 1.5, this is your output. Here's your input, here's what your output should be. You want to go through and test with their values so you can see if your program is coded properly. You know, you might not get any syntax errors. So if I run this now, I hit the play button, my console window shows me my output. I can put in 1, and then I get a value of y equals 4.59, blah, 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 so on. Now, you'll notice I didn't code the value of y, so what I have is a bad result. So I don't get what is expected. So now I know my program's not done. I know I have something wrong. I'm going to clear that output, and I'm going to go and type our answer in. So let me just type this out, and I'm going to create a syntax, or I'm going to create a logical error in here so you can see what will happen. And I won't talk while I type what I'm doing is interpreting this into one mathematical operation. So you can type along with me as we do that. I'll try not to talk so I don't mess it up. Okay, y equals, let's say, open up my parentheses, x2, x2, Now you notice when I open up a parenthesis, it closes my parentheses for me. So if pay attention to that, because if you add an extra one that's not there, then you will get into problems, or shouldn't be there. And we end all statements with a semicolon. Not sure this is right, because I went through it quickly, but that's my interpretation of this. Now let's see if it's right. So that's, you know, what you're coding. You're trying to code the solution. We'll hit the play button, and if we get syntax errors, like we do right here, what you have to do is go fix it. So you can't go on until you get rid of your syntax errors. So let's see, I missed something along the way. Enter a value for x, so the user will enter in a value. And then I missed this step, x2, I need to square that. So I'm going to, before I get down here, instead of everywhere that it says x2, instead of saying x times x, I'm just going to create a kind of a temporary variable and say x2, this is the variable name here, is equal to x times x. Okay? All right, went back and added that. By the way, this is all white space, so it doesn't matter if it's there or not. So that was a step here where it says, oh, let's see, hint, multiply x by x to get x squared. So that's that step I forgot to do real quick. So x2 is x times x. Now, by creating that shorter variable, you'll see I have it in my formula 4 times, because x2 is here, 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 and here. If I didn't have this line 17, every time I do that, I would have to replace it with x times x, and that's just more variable names that that would cause potential issues. So we can shorten up our calculation by creating a temporary variable that does that. Same with pi. If I did pi here, which I'm going to do next, I'm going to create that pi 2. So see pi squared. We're going to create float, and then the variable pi 2 is equal to the value of pi times the value of pi, and then a semicolon at the end there. So again, every time I have pi 2, notice my variable name, I'm missing it somewhere else here. That's my, I have a syntax error because notice I have pi here. So I have x2 divided by pi 2, or pi raised to the power of 2, times x2 plus 1/2. That's this first part here. Where I have pi raised to the power of 2, I could do 3.1415 times 3.1415, or I created this little temporary variable called pi 2 equals pi times pi. So it's just a shortcut. Hopefully you're following that. Now I am missing this one over here, but I'm going to run it now. Let's run it again. I want to give you a logical error. So let me hit clear again so we can get rid of our syntax errors. And now when we run it, okay, hit play. And now down here in my output window, I come to this line of code, enter a value for x. Let's put in our sample output. So if I put in 1, I don't know what this error is, but let's just ignore that. Maybe I waited too long. Put in 1. Oh, I think I clicked out of it. That's weird. Okay, put in 1 and hit enter. And it says y equals 101321. Now, I didn't get any syntax errors. My program ran just fine, but my expected output does not match my actual output. And this sandbox tells me you get a bad result for x equals. You're getting a bad result for what you're trying to do. So that tells me if my output doesn't match what it should be, I'm not ready to turn this program in. It's not done. So I want to go back and fix my error. Now, just upon looking, I already know I missed something over in this one. 1 plus x squared divided by, and it's the whole part of the formula. So divided by pi 2 times x2 minus that one, and actually that 1 should be a 0.5. Okay, let's see how we're doing now. So take a minute if you're coding along and just check out your parentheses, see how we're doing, and if I hit run, okay, that's expected because I have probably one too many parentheses. This is a good lesson because when you're coding, you want to open one and this one here matches the one at the end. But you'll notice this is highlighted, so that one there is matched with this one. This one here matched with this. This one here is matched with that. Okay, so this part of the formula is good. Now if I highlight this one, where is my closing parenthesis? I don't have one. Notice I highlighted it and there's no closing one. So I'm going to go all the way to the end and add another one. Let's test out now. Here. Open plus that. Divided by, I'm missing my division symbol here. Pi squared times parenthesis x2 minus 0.5 times x2 minus 1/2, and then my 4 closing parentheses. Okay, the formula should be good now. Okay, we'll try it. Maybe it's not. Let's check one more time. Expected closing parentheses before line. Okay, this is good too. Line 21, that keeps the same. Character 71 is probably what that is. Your expected a parenthesis before the semicolon. So I have a missing parenthesis somewhere. Maybe I have too many. There we go. And clear my output again. Stop it from running. Clear everything out. Okay, so I got my play. Notice how I interpret those syntax errors because you can't go on until you fix them. And then we'll hit run. Now let's test our input with our output. So I'll hit 1 again. And I am getting y equals 0.07. So I'm still off. And I still get an error there that says, no, you're not right. Let me test negative 1.5. Okay, negative 1.5. Okay, I'm still wrong. So let's go back. This is good because you don't want to turn in something that logically is wrong. So we're going to go back and I'm going to pause this and step by step through this to see where my syntax, my logical error is, and then we'll fix it and move on. Let's see. Okay, I got it correct. Upon further inspection, I was missing my closing bracket here and not here. So, pause the video, check yours, check your brackets. Make sure we're all lined up now. So the first part of the formula looks fine. But here, now when I highlight this first parenthesis, it matches the end parenthesis. And then x2 goes around, should go around this one here, and then here and here, here and here. So we're golden now. Check them all out, make sure your closing parentheses match. Now, if I were to do this again, the formula, I would, when I open a parenthesis, I might remove it personally because I know I'll have to close it later on. It just, because this compiler and other compilers, when you open something, it automatically closes it. In my head, when I was doing the formula, I would close one too, and I ended up with too many, or not enough. Okay, so now let's run it. So let's go back down, test it. So we'll hit run. Again, we're going to hit 1 is our sample input, and then our output matches exactly the expected output, and look at, we get a congratulations, your mission is complete. So let's run it again and test our next value, minus 1.5. Great, we still get a green, and then let's check 12.345. 12.345. 12.345. Okay, 101.057. Awesome. We've got it. We've got all of our test data runs properly. You can run it with different values, 5, and you can check your answer. That's the correct answer, but this just says this is a program, so it says we don't know if that's correct. But that's no big deal. But if you test it against your sample input, should be good. 1.5. Yep. All right. So now we know how to use this. This one a little bit longer because I was going through the formula with you. But when you do an assignment, if you get stuck on things like that, that's where you would then email me and reach out and say, hey, I have the code, but my answers aren't coming out properly, or I'm not sure what they're asking for, and we would figure that out. But I want to tell you one thing about the danger of using this environment. So I went through and I spent almost a half hour. I've got my output, I got my code right. If I hit this download button right here, it will download and save my code. So you're going to want to do that when you turn these in, because I asked for the CPP files to be submitted. So I'm going to download it, and I'm going to call this lab 1. I'm not going to put a period in my file name because that causes issues with the other compilers, but lab 1.4 dash 40-1, and it's called floats, operators, and expressions. Call it whatever you want. Download it. So when you hit this download button, you have your code downloaded, and I just opened it up, and it opens it up in the Visual Studio because that's the default program on my computer to open up CPP files. In Blackboard, I always say, submit your CPP file. So when you hit this download button, it applies the CPP extension. I just saved mine to my desktop. So let me minimize all my things, and you can see, here's my desktop mess, right here. Here is the file I just downloaded. So I would go, in Blackboard, I would then go navigate to the desktop, submit that as the answer for that lab. Go back to here. But if you're coding in this, and imagine you have a program that's taken you days, there's no way to save it. So this button opens up other programs. This button, don't hit it, it wipes everything out. So if you've not downloaded it yet, and you hit this, you start back to scratch, to 0. And that can be frustrating if you do that on accident and you have your whole code already programmed. So be very careful on that. If you've downloaded it, then you can simply open it back up and it's there. But if you don't, there's no like save in the middle type of thing with other things. So be very careful on using the Sandbox environment only, and then perhaps periodically download your program so you have a copy of it saved as you're going through it. So that's how we use the Sandbox. And then when you go on, to another lab, so that was this one. This does not keep track of your code, and it doesn't like grade your code from there to the next one. So I went on to the next lab, integers, and I'll go back to my floating one and look at it's all gone. So this is the sandbox, just like a sandbox at a playground. You leave the sandbox and some other kid comes in there and messes it all up. That's what happens when you get out of your sandbox here. So be very careful about that. And might, because of that danger, it might be a good reason for you to instead, go back to Unit 0, instead download and install Visual Studio and work through the environment that way. So setting up our work environment. Again, these videos shows you how to do the download and then how to create a C++ file in Visual Studio. If you have another compiler you want to use and your experience with it, that's fine as well. But we've got lots of tools. The Sandbox to get you started, Visual Studio to kind of more long-term is a better option. So thank you for listening. I'm looking forward to a great semester with everybody. I love C++. It's a fun language for me to use and a fun class to teach. So have a great day.